Hello guys, welcome back. In today's video, we are going to look at inversion of control and dependency injection. Let's go ahead and define what inversion of control is, okay? Inversion of control is a software design pattern that allows us to shift the managing of the control flow of an application to the framework or runtime upon which the application is utilizing, okay? So in a traditional application where we don't use inversion of control, the developer is usually responsible for managing the flow of the application. But when you utilize inversion of control, you are going to delegate that responsibility, which is managing the flow of the application, to the framework, runtime, or container upon which the application is running. So now we've established what inversion of control is. So let's go ahead and take a look at what dependency injection is. So for us to understand what dependency injection is, we have to look at it separately because that's two words, dependency and injection. Let's take a look at what dependency is. A dependency is basically something that you depend on, okay? Your clothes are a dependency to you. Your house is one of the dependencies you need. The food you eat is one of the dependencies you need because you all depend on these things to function properly, right? You need clothes to function properly. You need the food to function properly. You need a house to sleep in to function properly. So all these things are your dependencies. Let's move that into a software development word. We can see that the dependencies and applications are software or piece of code that our application needs to function properly. I said that a dependency to our application is any piece of software or code that our application needs to function properly. So now we've established what dependency is. Now let's add in the injection part of the statement, okay? So dependency injection simply refers to manually injecting the dependencies. That is, when I use injecting, I'm saying manually providing our application the dependencies they need to function, okay? We are going to be responsible for injecting, that is, putting that dependencies into the part of our application where it's needed, right? We have already established what inversion of control is, and you should know that dependency injection is one of the methods to achieve inversion of control. However, dependency injection is not the only way that inversion of control can be achieved. Event-driven systems also employ inversion of control. So you've been using it all this time when you're working with JavaScript. The event loop is provided by the runtime, while you write code that will be called by the event loop when the event occurs. We've delegated the part of calling the function that's going to be fired when the event occurs to the framework, which in this case is the runtime. So let's look at how we can implement dependency injection. So I'm going to show you one of the ways of implementing dependency injection. Let's say we have three classes: an authentication service, a notification service, and an email service. Now we want to log in a user and send them a notification anytime their login is successful. So let's see how this is implemented in a tightly coupled system, that is a system where dependency injection is not utilized. So I'm going to go ahead and create, first of all, a notification service. I'm going to say class notification service. If you can spell notification correctly, notification service. And this class is just going to have one method, send. If you can spell send correctly, this is going to take in a message, which is going to be a string, a customer ID. Let's put in the comma, sorry. This is going to be customer underscore ID. It is going to be string. It is going to be console.log message, and this is going to be the message. The next thing we want to log at is the customer, and this is going to be the customer ID. Now we've implemented the notification service. I will go ahead and implement a second service. This is going to be class email service, right? And this email service will have just one method in it too. This is going to be send. This will accept an email, which is going to be of type string, a body, which is going to be of type string, and a subject, which is going to be of type string. So here, I just want to go ahead and I want to use console.table instead, so it makes more sense. Console.log instead, let me not use table. This is going to be the email, going to be email. Next one to look at is the bodies. This is going to be body. Then this is going to be subject, and this is going to be subject. Right? Nice. So now that we've created email service and the notification service, let's go ahead and create the authentication service. So I'm just going to go ahead and copy all of this. Just give me a minute. Then I'm going to come over here and I'm going to paste all of this. So now this should be notification service. Add a test ignore. You don't have the same notification. You have send. Customer ID should be 1, 2, 3, 4. This should be send, and So yeah, this is our login function. So we have a function that accepts two arguments, a username and a password. Then we check if the user is authenticated, and if they are authenticated, we create a new notification service and we create a new email service. Then we send the user a notification and we also send them an email. But this is what is known as tightly coupling, because this authentication service is responsible for creating an instance of this notification service and this email service. And you can agree with me that this email service and this notification service are actually dependencies that this authentication service need. It does not make sense for this notification service and this email service to be tightly coupled to this authentication service, because what if there's a change in this notification service that is going to break this authentication service, and if there's also a change in this email service, it's going to break this authentication service. And let me show you what I mean. I might just go ahead and add a constructor to the email service. This is going to take a constructor. You see, now that I've added a constructor, you can see that we get an error on the email service, right? We need to pass in that constructor argument. So that does not make sense. So what we can do is to move this instantiation out of this class. I've removed the constructor argument from the email service because we don't need it. The next thing we are going to go ahead and do is to, first of all, let me delete this, and let me also call it here and delete this one. Now, what is going to happen is I'm going to add a constructor to this. So this is going to be constructor. This is going to take for private notification service. This is going to be notification service. And the next argument we're going to take is our email service that we want to do of type email service. So this is going to be notification service. This is the notification service to send this into this to email service to send. And now you can see that the error goes away, and we are no longer creating an instance of the notification service or the email service inside of the login function. Instead, we are sure that this notification service and this email service is going to be provided to this function at runtime, okay? Such that now if I come here and make a change to the email service, let me go ahead and add this constructor back. It's going to be private type, which is going to be a string. You can see that we don't get any errors anywhere, because at the end of the day, this authentication service is not tightly coupled to this email service. See, basically, it doesn't even know anything about this service, this email service. The only thing it knows that it has a send method that we can use to send the user an email. Same thing with the notification service. We don't know anything about notification service from this authentication service. The only thing we know is that this notification service is going to have a send method defined on it. Okay, let's go ahead and delete this constructor we added to the email service, because we don't need that anymore. So delete that. So let's create an instance of this authentication service to see how it works. First of all, we need to create an instance of the email service. So this is going to be email service. This is going to equal to new email service. We need to do the same thing for notification. It equals to new notification service. Now we need to create an first auth service. That's very correctly is equals to new authentication service. This is going to accept the notification service and then accept an email service. So basically, this is it, right? This is how we now inject those dependencies into this authentication service while we are trying to add an instance of it. Okay, so basically, this is how we implement dependency inversion in a nutshell. There are lots of ways you could do this. I'm going to leave this here. So let's go ahead and let's look at the advantage of using dependency injection. So dependency injection allows our code to follow two important solid design principles. That is the interface segregation principle, which states that our classes should rely on composing multiple interfaces together as opposed to relying on one big interface. Dependency injection also follows a single responsibility principle, which states that the classes and functions in your application should only be responsible for doing one thing, and thus they should only have one reason to change. You can see that this authentication service is only responsible for authenticating the user. This email service is only responsible for sending the user an email, and this notification service is only responsible for sending the user a push notification. So this will only have one reason to change. Same thing with the email service, it only have one reason to change, and same thing with the authentication service, it only have one reason to change, because at the end of the day, they are all just doing one single thing, right? And by following the interface segregation principle, we are relying on composing multiple interfaces together, which is what we are doing inside of this constructor, right? So instead of having one big class that has the email service and the notification service defined defined on it, you can instead state that this authentication service requires on as many classes as needed. Now, if there's a project service, you can add that here. If there's a billing service, you can add that here. If there's a login service, we can add that here, right? So at the end of the day, you can see that our classes are relying on posing multiple interfaces together to make up that class instead of just one big interface, right? So the next advantage of dependency injection is that the classes in our code is going to rely on interfaces or abstractions and not complete implementation. Thus, changes in one class will not ripple throughout the entire system and cause a break in production, which is what I defined when I told you that by making a change here is not going to affect here, right? Because this does not rely on the complete implementation of the notification service. Instead, what it relies on is an abstraction, which is an interface of this notification service, or the interface, which is this email service, right? We don't rely on the concrete implementation of the email service. We just rely on that the interface, that's to say, whatever we pass as this email service or this notification service is required to fill out this email service type or this notification service type first, right? So that it could be of any other type, as long as it has a send method defined on it, we are sure that we can use this inside of this authentication service. So the third advantage of using dependency injection is that the dependencies in our application can be mocked or subbed for unit testing. And we can also test each component of our code individually, right? Simplifying test case creation and execution. Because since this requires all abstractions and not concrete implementation, we can easily stop this for a mock when we are trying to run a test. Just make our life that bit easier when we are trying to write tests for this code. So another benefit is that components can be swapped easily and replaced with different implementations, making our application incredibly flexible and reusable. This approach promotes code reuse across different parts of your application, enabling the application to adapt to changing requirements without major code rewrites. Okay, so if we have to change this email service, or if we have to change this notification service in the future, we are sure that we are only going to have to make that change here, and we don't have to go back into this authentication service to make that change again. No. And let's say we have a notification service that needs us to do something else, we can easily swap that for this, and as long as it is fulfilling this notification service, you understand? Let's say we have a super type of this notification service, we can also pass this into this authentication service, and that is going to work because at the end of the day, it still fills out this notification service. So this dependency injection allows the components in our code to be easily swapped for other components. Okay, so another benefit of using dependency injection is that dependencies can be configured externally through files and frameworks without the need to modify code to change dependency. What's that saying is, here we are doing manual dependency injection by ourselves, but we can use a dependency injection container to handle the dependency injection, and then we don't have to worry about writing code that is going to inject this notification service and this email service into this authentication service. The library or the framework is going to handle all of that for us. It's going to make our code that less bogus by eliminating all of the boilerplate code. However, anything that has advantages has disadvantages. So let's look at some of the drawbacks that come with using dependency injection. So there's an excessive dependence on configuration file that makes our code less readable and harder to debug. The second drawback of using dependency injection is that resolving dependencies at runtime can incur a slight performance cost, especially in high performance application. You might need some performance critical optimization in some sections of your code. And last but not the least, tracing issues through multiple layers of abstraction can be very challenging in a loosely coupled system, and it may require specialized debugging tools or techniques. Okay, so that's going to be it for this video, guys. I hope you found this useful and interesting, and I hope you liked the video. Please give it a like if you actually did. Subscribe to the channel so you can get access to all of our videos in the future as they drop. Make sure to leave your thoughts about this video using the comment section. I'm going to see you in the next one.